My name is Elea. I work at OVHcloud for 9 months. I have beginning by an internship. Now I'm a working student in the AI team. My job is to write some notebooks, some tutorials. So my job is to write some tutorials, some notebooks, also apps and blog posts about AI and about our product. And today I will present you a tutorial or a use case about the AI notebook solutions. First of all, I will introduce you the subject. In AI, when we talk about machine learning and deep learning, we often deal with examples about computer vision or NLP. By NLP, we can think about chatbots, virtual assistants, sentiment classification or analysis. And when we talk about computer vision, we have the image classification, the object detection, and the image instance segmentation, for example. But today we're going to see another subject, which is the classification of sounds. We are going to follow the different steps. The first one, we will introduce the subject by presenting some use cases about the classification of sounds. After that, we will see the different objectives, and I will present you the database we will use. We also need 2 audio libraries. I will present you after. We will make a test on an audio to use these libraries. After that, we will make a preprocessing phase for our data. Then we're going to build the model and train it, do some tests, and if it's OK, we will save the model for future inference. OK, so let's go for the introduction. Audio or sound classification is a technique with multiple applications in the field of AI and data science. The first one is the acoustic data classification. We can identify the sound location according to the environment where it was recorded. Then we have we can differentiate the environments, such as homes, restaurants, school, and so on. And acoustic data classification has a role in ecosystem monitoring. Indeed, we can calculate the abundance of fish in a part of the ocean according to the acoustic data. The second use case is the environmental sound classification. We can recognize urban sounds. It is also used in security systems. For example, we can detect broken glass. We can use it in predictive maintenance to obtain difference of sounds in factory machinery. And the last one, we can use it to differentiate animal sounds or calls for wildlife observation and preservation. We can also use it for music classification. So we can classify music according to factors, for example, the genre or the instruments. And it has key role in audio libraries, organization by genre, improvement of recommendation algorithms, and discovery of trends. And to finish, listener preferences through data analysis. You can see this type of use case in Spotify or Deezer. And last but not least, the natural language classification. In other words, is human speech classification. And it's common in chatbots, in virtual assistants, and in a text-to-speech application. Today, we will use a dataset of marine mammal sounds, and we're going to classify it. I will present you the objective. We will build and train a model with AI notebooks, and we will use 1 GPU. The use case is a database named Best of Watkins Marine Mammal Sound Database. You can find it on Kaggle. It is available for free, but you can't use it for commercial effect. And this database is composed of 55 marine mammals, and it was created by William Watkins. And if you want to see more information about it, you can find it on the website, and we can do a test on a sound. Okay, it's just for an idea. And we go back to the tutorial. Here you have the data, how they are split. And if I go on my data, you can see that all the folder names correspond to the marine mammal's name. And just for information, here we will take only the first 45 places because it's sufficient in our tutorial. We can talk about the data format. You know that for sounds there are several formats like MP3, for example. And today we will use sounds with WAV format for waveform audio format. And we can't use it directly, so we will need to do a preprocessing phase to transform it into a CSV file row. Okay, so just here we have the different steps, and I will begin by talking about libraries. We're going to use two of them. The first one is Librosa. It's the most important. Librosa is more a module, a Python module for audio signal analysis. And thanks to Librosa, we can extract some key features. For example, the tempo, the chroma energy normalized, the male frequency substral coefficients, the spectral centroid, the spectral contrast, the spectral hold off, and to finish the zero crossing rate. With Librosa, you can have several parameters. I'm just going to present you some of them, and you can find more information about it on the website. First, I will import a Librosa module. And we're going to make a test on a sound, so I just write the path. Here we will take the first sound from an Atlantic spotted dolphin. Okay, we are ready to load and decode the data. Now I will use a second dependence, which is IPython. And by IPython.display.audio, I can play an audio directly in the notebook. Okay. Okay, so here you have heard the sound of an Atlantic spotted dolphin. And to present you the different parameters of Librosa, I will take this sound and this soundtrack to present you the different parameters. First, I import matplotlib because I need it to display the graphs. We will talk about waveform. Waveforms are visual representations of sounds with the time on the x-axis and the amplitude on the y-axis. And they allow quick analysis of audio data. And we can display it. Oops, sorry. Okay, now we turn to spectrograms. Spectrograms are visual way of representing the intensity of a signal over time at various frequencies present in a particular waveform. So just here you will have two examples. Okay, so don't worry about the warning. Now we will talk about spectral hold off. Spectral hold off is a frequency below which a specified percentage of the total spectral energy is reached. By percentage, we can take 85%, for example. And the function librosa.feature.spectralolof calculates the attenuation frequency for each frame of a signal. So just here, you will have an overview of the graph. Okay, chroma feature. It's the best thing to analyze music and musical features whose pitches can be meaningfully categorized and whose tuning is close to the equal temperament scale. Again, I will show you the overview. And the last one is the zero crossing rate. Zero crossing rate occurs if successive samples have different algebraic sign, so positive or negative. The rate at which zero crossing occurs is a simple measure of the frequency content of a signal, and the number of zero crossings measures the number of times in a time interval that the amplitude of speech signal passes through a zero value. So from positive to negative or from negative to positive. And the display of the graph. Okay, this previous analysis of the sound will help us for the data preprocessing part. The first step is a transformation. Indeed, we can't use sound directly, so we will convert it into a CSV file. So each sound will begin a CSV file row. For example, if I have 100 of sounds, I will have only one data.csv file with 100 of rows. I import NumPy because I need it. Okay, I will define the column names by header. The first one is a file name. The second one is the length. And if we move, we can see, for example, roll-off that we saw before, the zero crossing rate. And at the end, we will have the label, which is the name of the marine mammals. Then I will create the data.csv data frame. I will also define the marine mammal's name for two reasons. The first one is that we needed to access to each folder to analyze sounds and to convert it. And the second reason is that the marine mammal's name will be the labels. By the following code, I can calculate the values of several parameters from LibRosa, but I won't run this cell because it takes time. We have around 12,000 of files, so it's for 30 minutes, but I did it before, and you can see the data.csv file just here. Just for information, if we take an example of classify a dog or a dog breed, we can't do it if we just have the size of the dog and the color. You need more information, for example, the dog nose, the dog legs, and much more. So it's the same for sounds. Okay, now I will create the data frame with Panda of my CSV file. So here we have an overview. We can also display the size of this data frame. We will need the number of the columns in order to define the input and the output of the neural network, and the data frame types. Okay, we will move on to feature extraction. In the preprocessing, feature extraction is really important because we're going to define the inputs of the neural network and the output. What is the output? It's the label name. So, for example, an Atlantic spotted dolphin. But we can't use directly text. We have to encode it. And you know that we have 45 classes. So our labels will become 0, 1, and we will have labels from 0 to 44. About the inputs are all other columns, except the file name, because it's not relevant information. Again, we will use a standard scalar function because it allows us to standardize features by removing the mean and scale it to unique variance. Okay, so we obtain the inputs. And the last step before building the model is to split data. Basically, we will take 80% for training and 20% for the validation set. Now it's done, we can build the model. Here you have an overview of the neural network. All hidden layers use a ReLU activation function, and the output layer used a softmax function. We also need a dropout to avoid overfitting. Okay, I build the model and I print his summary. Now it's done, we can train our model and evaluate it. I'm just gonna launch the training. Okay, so for the training, we have a batch size of 128. And for the optimizer, we choose Adam because we have best result with it. According to the loss, we calculate it with a sparse categorical cross-entropy function. And for the metrics, we take accuracy. The training is during 100 epochs, because it seems to be sufficient. And you can see that it's quite fast, because we haven't got heavy data, and it's almost finished. If we have, for example, images, it could be not as fast as now. Okay, it's good for me. We will display loss and accuracy curves. So first, the loss. Here we can see that for the training set, we have a loss of 0.07. And for the validation set, we have a loss of 0.24. I think it's quite good. It's important to display graphs because we can see if there is an increase of the loss, for example, and we can have a problem if it's the case. For example, it could be overfitting. We will do the same for the accuracy. Okay, so for the training set, we have an accuracy of around 96%, and for the validation, around 93%. The results are quite good. So we're going to evaluate the model before making some tests. Okay, let's go for the test. Here we assume that we have two new sounds, that we don't know the labels and we don't know which is the marine mammal. I will skip the preprocessing phase because it's exactly the same as before. I just have removing the file name for the columns because we haven't got any information with it, and the label because it's what we want to predict. Okay, so quickly I create the CSV file. Okay, and the data frame. You can see the two sounds, and next we will transform it again. Let's go for prediction. The first step is to generate prediction for samples. Okay, so here you can see, for example, what is selected is the predictions for the first sound. So here you have several values. To be exact, 45 values, which corresponds to the 45 marine mammals. It's not very easy to read it. So we need to take the highest value, and to be more precise, the argument of the highest value. In order to do this, we will use an argmax. So for the first sound, it's the class 44, and the second one is the class 0. But it would be better if it has the label's name. So we will use an inverse transform. And here we can see that for the first sound, it's a sperm whale, and for the second one, it's a nautic spotted dolphin. Now that we have done some tests, we can save the model for future inference. You can see on the left that we have a folder named saved model. It's not only a folder, it's an OVHcloud object container stored in our object storage. Why it's important? Because when you will save your model in this folder, you can use it in another notebook without having to retrain your model. And you can also develop some apps or some web service, for example. So I'm going to save it. And I will check that all it's OK. OK, and to be sure, the model summary. OK, so now we have a model trained and saved. And we will use again the object container named saved model to develop a little app with Streamlit. Just here, you can see the home page with some information about the marine mammals we are able to predict. And the most important is the prediction part. So here I will just choose a new sound. So test 1. OK, we have some information like the file name, the file type, and the file size. And we can also display the audio. OK, and we're going to predict. Here we have a raw seal. So for this prediction, I haven't trained a model again. I use the model I saved before in the OVHcloud object container. We can make a second test. Okay, again the name and the type. And to finish the prediction. Here I choose only one file. If you want to test some files, it's possible, no problem. You have just to modify the code. I haven't got the time to explain you how to build a Docker file and to create a job and to launch a job with AI training, but you can do it fast and it's very simple. Let's go for conclusion. There are several things possible with AI Notebook. Today we have seen how to visualize data, how to make data preprocessing, to define and train a model very quickly. Next, we have saved and stored the model in an OVHcloud object container. And with AI training, we have seen that it's possible to develop a little app or web service. If you want to find out more, you can refer to our GitHub repository, AI training example. And you can also check our documentation if you want to launch this notebook and to test it. I hope you have enjoyed this tutorial and thank you for listening. If you have any questions, don't hesitate.